Number 7, use the concept of electron configurations to explain why the number of valence electrons in metals tends to be less than the number in most nonmetals. Alright, so we're using electron configurations. Okay, that's the stuff like S, P, D, and F, all that jazz. Okay, we're using these ideas to explain why the number of valence electrons in metals, okay, right, left side of the periodic table, have fewer valence electrons than most nonmetals, right, right side. So we're really looking at the S and the P blocks here. And what it amounts to is most metals have their highest energy electrons in the S orbital, while nonmetals, okay, and with the exception of hydrogen and helium, every single nonmetal has their valence electrons in the P block. Okay, so while nonmetals, or should I say most nonmetals, like I said, with the exception of hydrogen and helium, have their highest energy electrons in the P orbital, and that's in addition to S orbital electrons. And so these nonmetals, not only do they have the exact same S orbital electrons that the metals have, they have additional P block the valence electrons. So that's why most metals have more valence electrons than metals. And again, the exception there is hydrogen and helium. We just have S block electrons. 8. How does the behavior of electrons in metals contribute to the metal's ability to conduct electricity and heat? Well, that's pretty simple. The mobility of electrons in metals, the mobility of the electrons is the foundation for their ability to conduct both heat and electricity. Okay, that mobility, the behavior of the electrons, their ability to move, the delocalized nature of them, that's the foundation for why they can do that. Okay? It's the only reason they can do that.